Good morning, everyone. Today I'm going to discuss the part of module 2, that is V and V limitations. So this is our verification and validation. So what are the limitations we will discuss? And before going to discuss this, we will start how verification and validation affects the software engineering and software testing. So let us see the cases of each and everything in detail. Major objective of this chapter is this particular unit is V diagram. It provides the basis for every type of software testing, then various verification activities, various validation activities, how to perform verification at each stage of SDLC, and various validation test plans. In previous unit, we have already discussed a lot about V diagram, which provides these insight. Testing can be implemented in same flow as SDLC. So here we are talking about SDLC and SDLC. Okay. Testing can be broadly planned in two activities like verification and validation. So these are the two activities. Okay. Testing must be performed at every step of SDLC. So this is our SDLC. Define a specification, we check the specification. Design, we check the design. Coding, we test the software or different modules. And if all the coding is done for different modules, we will integrate the system. And finally, this will give us tested system. V diagram supports the concept of early testing. V diagram also supports a parallelism in activities of development, developers and tester. Once developer starts the developing activities, parallelly the tester starts the testing activities. The more you concentrate on V&V process, more will be the cost effectiveness of the software, and testers should be involved in the development process. Since testing is a critical element of quality verification and validation also relate to quality of the software. So it can said that all testing activities can be seen in the form of verification and validation. So this is very important. In this unit, the V diagram already explained to get a clear vision of verification and validation activities in SDL6. Okay, this expanded V diagram called the V and V activity diagram, and it gives more insight about this. So let us start verification and validation activities. So it will start with end user. First of all, end user is started. The requirement gathering phase is started. And this V and V activities, it can be understood in the form of diagram, which is already shown here. To understand this diagram, we first need to understand the software development lifecycle phases. After this, verification and validation activities in those SDLC phases. Okay, and this diagram uses different phases. First is requirement gathering. This is our first phase. The need of the user are gathered and translated into a written set of requirements. These requirements are prepared from the user's perspective only and do not include any technicalities according to the developer. Now come to requirement specification objectives. In this phase, all the user requirements are specified in developer's terminology. Okay. Up to this, only user is involved. Now, developer's terminology has been involved here. The specified objective from the full system which is going to be developed are prepared in the form of document known as software requirement specification. You know very well about this. Now come to third, functional design or high level design. Okay, functional design is the process of translating users requirement into a set of external interfaces. The output of the process is the functional design specification, which describes the product's behavior as seen by the observer external to the product. The high level design is prepared with SRS, that is uh, already completed in second phase. So, and the software analyst converts the requirement into usable product. In high level design, the software system architecture is prepared and broken into independent modules. Therefore, an HLD high level design document will contain these items. At micro level, number one is overall architecture diagram. Okay, number one is overall architecture diagram along with technology detail. Second thing is functionalities of overall system. With the set of external interface, then list of modules, then brief functionality of each module, and finally interface. Let us discuss here. And finally interface relationship among modules, including dependencies between modules, database tables, identified along with identified along with key elements. So these are the high level document. Now fourth is internal design or low level design. This is means with respect to machine. Since HLD provides the macro level details of a system, an HLD document cannot be given to the programmers for coding. So the analyst prepare a micro level design document called internal design, low level design. Both are synonymous terms. This document describes each and every module in an elaborate manner so that the programmer can directly code the program based on this. There may be at least one separate document for each module. Now come to fifth one is coding. If an LLD or low level design document is prepared for every module, then it is easy to code the module. Thus, in this phase, using design document for a module, its coding is done. After understanding all SDLC phases, we need to put together all verification activities. Okay, already shown here. So this is our requirement gathering is coming under verification, and requirement specification also coming under verification. Functional design, high level design coming under verification. Then internal design, low level design coming under verification, and coding is also coming under verification. So verification activities are performed almost at every phase. You can easily see that it is everywhere. Therefore, all the phases described here these all are the phases described here, will be verified. Okay, like here we have shown in this figure. Along with these verification activities performed at every step, the tester needs to prepare some test plan which will be used in validation activities performed after coding the system. These test plans are prepared at every SDLC phase. So here for requirement gathering, build acceptance test plan. For a requirement specification, build system test plan. Then build function and integration test plan for high level design, and build unit test plan for low level design. And then installation testing is also started, acceptance testing, system testing, functional testing, and unit validation testing. So these steps are validations. Okay, validations. And here whatever the user is going, whatever the developer is going to perform is coming under verification, and it is involved in all the phases of life cycle. So verification and cross verification is going on. Fine. When the coding is over for a unit or a system and parallel verification activities have been performed, then the system can be validated. It means validation activities can be performed now. These are executed with the help of test plans prepared by the tester at every phase of SDLC. This makes the complete V&V activity diagram. Okay, so this is our V&V diagram. So you must prepare this V&V diagram for examination. And very important thing, what is the outcome of requirement gathering and what parallel activities will be performed by the tester. So it is build acceptance test plan. Okay. Then at this step, requirement specification objectives. So here the tester will build system test plan, whole system, then functional testing plan and integration test plan, and then because it is micro level entity, it is micro level entity and it is macro level entity. So in this micro level entities, we will test all the modules. Okay, unit test plans. So what is verification? We have seen that verification is a set of activities that ensures correct implementation of a specific function in a software. What is the need of verification then? Can't we test the software in the final phase of SDLC? Under the verification and validation or V&V process, it is very important and very mandatory that the verification is performed at every step of SDLC parallelly. Verification is needed due to this. If verification is not performed at early stage, okay, there are always a chance of mismatch between required product and the delivered product. Suppose if requirements are not verified, then it leads to situation where requirements and commitments are not clear. These things become important in case of non-functional requirement, and they increase the probability of bug. Then verification exposes more errors. Early verification decreases the cost of fixing bugs, and early verification enhances the quality of software. Everything must be verified. Fine. In principle, all the SDLC phases and all the product of these process must be verified. Then result of verification may not be binary. Verification may not be the acceptance or rejection of product. There are many verification activities whose result cannot be reduced to a binary answer. Okay, binary means true or false. Okay, accepted or rejected like answers are there. Often one has to accept approximations. For example, sometimes correctness of a requirement cannot be rejected or accepted outright, but can be accepted with a degree of satisfaction or rejected with a certain degree of modification. Then come to even implicit quality must be verified. Fine. The qualities desired in the software are explicitly stated in SRS, but those requirements which are implicit and not mentioned anywhere must also be verified. And let us see what are the verification activities. Okay, so verification activities includes verification of requirement and objective, verification of requirement and objectives. Then second thing is verification of high level design, verification of high level design. Third thing is verification of low level design. And fourth thing is verification of coding. Fine. This is unit verification. Now come to verification of requirement. In this type of verification, all the requirements gathered from users' viewpoints are verified. For this purpose, an acceptance criteria is prepared. An acceptance criteria defines the goals and requirement of the proposed system and acceptance limit for each of the goal and requirement. The acceptance criteria matters the most in case of real-time system where performance is critical issue and in certain events. Like a real-time system has to process and take decision for a weapon within X second. Then any perform then any performance below this would lead to rejection of the system. Therefore, it can be concluded that acceptance criteria for a requirement must be defined by the designers of the system and should not be overlooked, as they can create problems while testing the system. The tester work in parallel by performing these tasks. First thing is the tester reviews the acceptance criteria in terms of completeness, clarity, and testability. Moreover, the tester understands the proposed system well in advance so that necessary resources can be planned for the project. The tester prepares the acceptance test plan, which is referred to the time of acceptance testing. So there are different objectives. So important things are correctness, unambiguous, consistent, completeness, updation, traceability, backward traceability, and forward traceability. So let us discuss each and everything. So how to verify requirements and objective. Requirements and objectives verification has a high level potential of detecting bugs. Therefore, requirement must be verified. Already we have stated that the tester used the SRS verification for objective. One characteristic of good SRS is that it can be verified. An SRS can be verified if and only if every requirement stated herein can be verified. A requirement can be verified, fine, if and only if there is some procedure to check that the software meets the requirement. It is a good idea to specify the requirement in quantification manner. It means that ambiguous statement of the language like good quality use usually may happen should be avoided. Instead of this, quantified specification should be provided like module X will produce output within 15 seconds of its execution. The output should be displayed like track A's speed is X. It is clear now that verification starts from requirement phase and every requirement is specified in the SRS document must be verified. But what are the points against which verification of requirement will be done? So there are these points. First thing is correctness. There are tools or procedure to measure the correctness of a specification. The tester used his or her intelligence to verify the correctness of requirement. There are some important points, okay, which can be adopted, and it can be changed according to situation. First thing is, tester should refer to other documents or applicable standards, compare the specified requirement with them. Second thing, tester can interact with customer or user if requirements are not well understood. And third thing is, tester should check the correctness in sense of a realistic requirement. If the tester feels that the requirement cannot be realized using existing hardware and software technology, it means that it is unrealistic. In that case, the requirement should either be updated or removed from SRS. Then come to unambiguous. A requirement should be verified such that it does not provide too many meanings or interpretations. Okay, it should not it should not create any redundancy in a specification. Each characteristic should be described using a single term. Otherwise, ambiguity or redundancy may cause bugs in the design phase. So what we need to verify in case of this, every requirement has only one interpretation. Only one interpretation. Then second thing is, every characteristics of the final product is described using single unique term. Okay, single unique term. Fine. Now come to consistent. No specification should contradict or conflict with another. Conflict produces bugs in the next stage. Therefore, they must be checked for real. First thing is, what we need to check: real world objects conflict, like one specification recommends mouse for input and another recommends joystick. So this is the conflicting statement. Second thing is logical conflict between two specified actions, like one specification require the function of to perform square root, while another specification requires the same function to perform square operation. So be careful. Then third thing is, conflict in terminology should be verified. For example, at one place the term process is used, while at some other places it has been termed as task or module. Okay, so this must be consistent. Then come to completeness. The requirements specified in SRS must be verified for completeness. We must verify that all significant requirements such as functionality, performance, design, constant attributes, or external interfaces are complete. Then check whether responses for every possible input, like valid and invalid, to the software have been defined. And third thing is, check whether figures and tables have been labeled and referenced clearly. Then updation. Requirement specifications are not stable. They may be modified or another requirement may be added later. Therefore, if updation is there in the SRS, then updated specification must be verified. If a specification is new one, then all the above mentioned steps, their feasibility should be verified. If a specification in a change in already mentioned specification, then we must verify that change can be implemented in the current design. Traceability of the requirement must also be verified, such that the origin of each requirement is clear, and also whether it's facilitate referencing in future development or enhancement documentation. There are two types of traceability we need to specify. First is backward and second is forward. So in case of backward traceability, check that each requirement reference its source in previous document. And forward is check that each requirement has a unique name, reference number in all the document. Forward traceability assumes more meaning than this, but for the sake of clarity, it should be understood in sense that every requirement has been recognized in other documents too. Verification of high-level design. All the requirements mentioned in SRS documents are addressed in this particular phase and work in the direction of designing solutions. The architecture and design is documented in another document, and this document is known as software design document. Okay, software design document, SDD. Like the verification of requirement, the tester is responsible for two parallel activities in this phase as well. The tester verifies high-level design. Since the system has been decomposed in a number of subsystems or components, the tester should verify the functionality of these components. Since the system is considered a black box with no low-level details considered here. The stress is also on how the system will interface with the outside world. So all the interfaces and interactions of the customer or any person who is in interfacing with system are specified in this page. The tester verifies that all the components and their interfaces are tuned with requirement of the user. Every requirement in SRS should map the design. The tester also prepares function test plan which is based on SRS. This plan will be referenced at the time of function testing. Okay. The tester also prepares the integration test plan which will be referred at the time of integration testing. So what we need to check whether size of data structure have been estimated appropriately, check the previous provision of overflow in data structure. Okay, check the consistency of data formats with the requirement, check whether data uses is consistent with the declaration or not, check the relationship among data object in the data dictionary, check the consistency of databases and data warehouses with the requirement in SRS documentation. Now, one important thing, architectural design. So it focuses on requirement of the structure of the software components and their properties and interaction, while interface design is also there. So actually, what are the different designs? First one is data design. Second is architectural design. And third thing is interface design. Okay, so already we have seen the cases of data design. It creates a model of data or information that is represented at a high level of abstraction, the customer or user's view of data. The structure of data has always been an important part of software design at the program component level. The design of data structure and the associated algorithms required to manipulate them is essential to create high-level quality application. Next is architectural design. So it focuses on the implementation of the structure of software components, their properties and interaction, and finally interface design. It creates an effective communication medium between the interfaces of different software modules, interfaces between software system and any other external entity, and the interfaces between a user and software system. So following a set of interface design principles, the design interfaces objects and actions and then creates a screen layout that forms the basis of a user's interface prototype. Verification of high-level design will consider all three designs mentioned, okay, and will become basis of effective verification. So this is the verification of data design. Now come to verification of architectural design. So in this verification of architectural design, what we need to do, check that every function requirements in the SRS has been take care of this design. Check whether all exception handling conditions have been taken care of. Then verify the process of transform mapping and transaction mapping used for transition from requirement model to architectural design. Then check the functionality of each module according to requirement is specified. Then check the interdependence of interface between these modules. Come to verification of uh, user interface design. So this is how check all the interfaces between modules according to architectural design. Check all the interfaces between software and non-human producer and consumer of information. Check all the interfaces between human and computer. Check all the above interfaces for consistency. Check that response time for all interfaces are within the required ranges. Okay, so these all are verification of high level design. Now come to verification of low level design. In this verification, low level design is considered. The abstraction level in this phase is low as compared to the high level design. In low level design, a detailed design of module and data are prepared such that an operational software is ready for this. STD is performed where all the modules and their interfaces are defined exactly, like every operational detail of each module is prepared, and the detail of each module of unit is prepared in their separate SRS and STD. Testers also perform the operations like and it is parallel. Okay, first thing is tester verifies the low level design, the details and the logic of each module verified such that high level and low level abstractions are consistent, and the tester also prepares the unit test plan which will be referred to the time of unit testing. Okay, how to verify the low level design, this is also very important thing. This is the last pre-coding phase. Low level design is last pre-coding phase. Fine. Where internal details of every design, each and every design entity are described for verification, the SRS and SDD of individual modules are referred to some point to be considered, like verify the SRS of each module, first thing is. Then second is verify the SDD of each module. And third thing is, in low level design, data structure interfaces and algorithms are represented by design notation. So verify the consistency of every item with their design notations. Organizations can build a two-way traceability matrix between the SRS and design, both high level design and low level design, such that at time of verification of design, each requirement mentioned in the SRS is verified. In other words, the traceability matrix provides a one-to-one mapping between SRS and the STD. So next question is how to verify the code. Coding is the process of converting low-level design specification into a specified language. This is the last phase when we get operational software which with the secure code. People have the impressions of that testing starts only after this phase, but not like that. However, it has been observed that the testing starts as soon as the requirement specifications are given and tester perform parallel activities during every phase of software development lifecycle. If we start testing after coding, then there is a possibility of that requirement specification may have bugs, and these might have been passed into design and consequently into the source code. Therefore, the operational software which is ready now is not reliable, and when bugs appear after this phase, they are very expensive to fix. Since low-level design is converted into source code using some language, there is possibility of deviation from low-level design. Therefore, the code must also be verified. The points against which the code must be verified are: check that every design specification in high level design and low level design has been coded using traceability metrics. Examine the code against language specification checklist. Verify every statement, control structure, loop and logic. Okay, and there are some points against which the code can be verified are: misunderstood or incorrect arithmetic procedures, mixed mode operation, incorrect initialization, precision inaccuracies, incorrect symbolic representation of expression, different data types, improper and or non-existent a loop termination, failure to exit. So, so next terminology is validation. Already described earlier, validation is a set of activities that ensures the software under consideration has been built right and it is traceable to the customer's requirement. Validation testing is performed after coding is over. What is the need for validation? And when every step of SDLC has verified, why do we want to test the product at the end? So the major reasons are: to determine whether the product satisfies the user's requirement as stated in the requirement specification or not; to determine whether the product's actual behavior matches the desired behavior as described in functional design specification. It is not always certain that the all stages till coding are bug free. The bugs are still present in the software after coding phase needs to be uncovered, and validation testing provides a last chance to discover bug. Otherwise, these bugs will move to the final product release, and validation enhances the quality of software. So that is our ultimate goal. So there are varieties of validation activities. Validation activities mainly divided into test plan and validation test execution. So first thing is validation of test plan. It starts as soon as the first output of SDLC, that is SRS, is prepared. In every phase, the tester performs two parallel activities: verification at that particular phase and corresponding validation test plan. For preparing a validation test plans, tester must follow the points like: tester must understand the current SDLC phase, and tester must study the relevant document in the corresponding SDLC phases. On the basis of understanding of SDLC phase and related document, tester must prepare the related test plans which are used at the time of verification testing. Under test plans, they must prepare a sequence of test cases for validation testing. So there are things a test plan have to be recognized which the tester have already prepared with incremental progress of SDLC. So first thing is acceptance test plan. This plan is prepared in the requirement phase according to the acceptance criteria prepared from users feedback. This plan is used at the time of acceptance testing. Then system test plan. This plan is prepared to verify the objective specified in the SRS. Here test cases are designed keeping in view how a complete integrated system will work or behave in different conditions. The plan is used at the time of system testing. Then function test plan. This plan is prepared in high level design phase. In this plan, test cases are designed such that all the interfaces and every type of functionality can be tested. The plan is used at the time of function testing. Integration test plan. This plan is prepared to validate the integration of all the modules such that all their interdependencies are checked. It also validates whether the integration is in conformance to whole system design. This plan is used at the time of integration testing. Then unit test plan. This plan is prepared in the LLD or low level design phase. It consists of a test plan of every module in the system separately. Unit test plan of every unit or module is designed such that every functionality related to individual unit can be tested. This plan is used at the time of unit testing. Now come to validation test execution. Validation test execution can be divided in these testing activities. First is unit validation testing. What is inside that unit validation testing? The testing strategy is to first focus on smaller building blocks of the full system. One unit or module is basic building block of the whole software that can be tested for all its interfaces and functionality. Thus, unit testing is process of testing the individual component of system. A unit or module must be validated before integrating it with the other modules. Unit validation is the first validation activity after the coding of module is over. The motivation for unit validation as compared to whole system are like um, since the developer has his attention focused on similar building block of the software that is unit or module, it is quite natural to test the unit first. Second thing is if the whole software is tested once, then it is very difficult to trace the bug. Therefore, debugging becomes easy with unit testing. And in third thing, in large scale projects, a number of modules may be there. At each module may be composed of tens of thousands of lines of code. Okay. In such a cases, it is not possible for a single developer to develop all the modules. There is a team developing working on separate modules sometimes. Some modules are sent to other organizations for development, and this requires parallelism in software development. If we did not have the concept of module, this type of parallelism would not have existed. Thus, every module can be developed and tested independently. Now come to integration testing. It is the process of combining and testing multiple components or modules together. The individual tested module, when combined with other modules, are not tested for their interfaces. Therefore, they may contain bugs in integrated environment. Thus, the intention here is to uncover the bugs that are present when unit tested modules are integrated. Then come to function testing. When integrated system has been tested, all the specified functions and their external interfaces are tested on the software. Every functionality of the system specified in the function is tested according to its external specification. An external specification is a precise description of the software behavior from the viewpoint of outside world like user. Therefore, function testing is to explore the bugs related to discrepancies between the actual system behavior and its functional specification. The objective of function test is to measure the quality of the functional or business component of the system. Test verifies that the system behaves correctly from the user or business perspective and function according to the requirement models or any other design paradigm used to specify the application. The function test determine if each component or business event performs in accordance to the specification. Second, respond correctly to all conditions that must be presented in the coming event or data, and third thing is move the data correctly from one business event to the next, including data stores, and fourth thing is initiated in the order required to meet the business objectives of the system. Then system testing. This testing is actually a series of different tests whose primary purpose is to fully exercise a computer um, based system. Then acceptance testing. When the system is ready, it can be tested against the acceptance criteria contracted with the consumer. And finally, installation testing. The testing does not test the system, but it tests the process of making the software. So with this, we finished the V and V specification. Okay, why V and V is very important. So this is part of module 2. So we have already discussed several things, V and V activities, verification and validation. In this module, what we have discussed, like how it is parallelly working. Okay, verification is performed at every stage of SDLC, uncover more and more bugs during earlier stages. Verification activities are verification of requirement and objectives, verification of high level design, verification of low level design, verification of coding, that is unit verification. After the completion of every SDLC phases, the tester prepare a test plan corresponding to particular validation testing. It means the tester does not does two tasks actually in parallel: verification of every stage and planning or validation of every stage. Fine. So with this, we completed this topic, verification and validation. You need to um, answer some questions. Okay. You need to answer some question. I will give you in assignment related with this part. Thank you very much. Have a nice day. Have a nice time. Bye bye. Take care.